Sonal පටන් අරගෙන කරගෙන යමු. කට්ටිය නිදි ඇති අද පරක්කුලන්ද මැසේජ් එක.
Okay.
Nice.
Can you all hear me and can you see the board? Can you all hear me?
Oh, we can hear.
Okay, so the plan is we'll do the 2023 paper and then do a matrix revision. Tomorrow we'll do some practice questions. That's the plan. So I'll start with the 2023 paper. I hope everyone has the paper. Okay. Okay, the first question. So consider the following set of numbers. So this is easy. First of all, you have to know what real numbers are. So real numbers are any number which you can think of. So all the numbers in this set comes for the real numbers. Second one is a list of irrational numbers. Irrational numbers are so they are repeating, not repeating. They are not repeating and they are not ending. Something like 5, 3.142, like likewise it will go till infinity. So these kind of numbers are called irrational numbers. So according to this one, this set, irrational numbers we have 5 and 3, 5 and root 13. Next one is a list of rational numbers. Rational numbers means any number you can write in the form of m over n, as in like a fraction. So the numbers which are rational are 0, root 16 to the power 104, 0.2333, 79, 4 over 7, 2 over 5 minus 23, 2 over 3, 0.29 bar. So these are the numbers which are rational. And the next one is list all the integers. So integers are positive numbers, negative numbers and 0. So according to this question, integers are 16 to the power 104, 79 minus 23, 0. How this one comes is that 16 to the power 104, 16 means 2 to the power 4 times 104, you get the answer 2, which is a integer. Okay, now I'll do the next part, B part. If you have any questions, just ask me. And if you have any part you can't understand, just turn on the mic and speak. Next one is simplifications. So what you do is you use the BODMAS. BODMAS means brackets of division, multiplication, addition, subtraction. So here so this is what you have to simplify. And first of all, what you have to do is you have to simplify the brackets, such as this one. So you can write 3 into 4 square means 16 minus 6 times 5 minus 4 times 2 times 2 is 4 plus 1, 5 times 3 minus 1 So when you simplify this one, 16, this minus times this minus 6, you get plus 6. 5 minus 4 times 5, 20, 20 times 3, 60. Then you get 16 plus 6 times minus 55. So here you get the answer 16 minus 330. So you get the answer 3 times four. Then you get minus 942. That's the answer. Is there any question, or shall I move to the next one? Okay, then I'll move to the next one. Okay, next question is 2 to the power 3 minus minus 5 times 3 over 8 divided by 2 minus 1. Here also BODMAS theory. So power, when you simplify 2 to the power 3, 8 minus 5 times 3 means minus 15 over 8 divided by 2, 4, 4 minus 1. So you get 8 plus 15 over 3. Get 23 over 3. So you get an answer 7.666. You can write it like this one. Okay, no? Shall I move to the next one? Okay, I'm moving. Next one is part 3. You have modulus there. So 3 minus 4 squared minus minus 4 mod plus 3 times mod 2 minus 2 squared mod over 4 plus 5 minus 4 squared divided by 2 minus 3 squared 4 minus 3 minus 8 plus 2. Okay. So what you have to remember here is modulus. So anything inside the modulus, once it comes out, it's a positive value. For example, minus 2 mod, you get the value 2. Minus, let's say 4, you get the value 4 once you simplify. So that's the theory behind it. If you simplify this one, 3 minus, here 4 squared, that means 16 plus 4 plus 3 times 2 minus 2 squared. So 2 squared is 4. 2 minus 4 is minus 2 over 4 plus 5, 9 minus 16 divided by 2 minus 9 times 1 minus 8 plus 2. So 3 minus, so 16 plus 4 is 20. Mod 20 means 20 plus 3 times minus 2 mod is 2. over 9 minus 16 over 2 is 8 minus 9 minus 8 plus 2. So 9 minus 9 get cancelled. Here you get 3 minus 20 plus 6 over minus 16 plus 2. You get minus 20 plus 9 over minus 40 minus 11 over minus 40. So minus gets cancelled out here. 11 over 14 is the answer. If you have any questions, ask me. Okay, I'm erasing. Okay, the next question is the C part. Answer the following questions. Find the HCF of 32x cubed y and 14x squared y squared using the listing factor method. So listing factor method means you have to list all the factors of these. So I'll take 32x cubed y. First of all, I'll take the numbers and then the variables. So 32 you can write 1, 2, 4, 8, 16, 32. So these are the factors of 32. Then for the x cube, you have x squared, x cube. And then you have y. For the 14 x squared, y squared, 14 you can write 1, 2, 7, 14. X squared, y squared, you can write x squared, y, and y squared. So these are the factors of 14 x squared, y squared. So the HCF is highest common factor. So the highest factor which is common to these two. What are the common factors? 2 is there. And x squared is there. Y is there. According to this, HCF is 2 x squared y. Okay, now I'll move on to the next one. Okay, next one is find the LCM. Find the LCM of two positive integers 120 and 150 using prime factorization method. So prime factorization means you have to write the number as a product of the prime numbers. So I'll take 120. So 120 can be written like 2 to the power 60. 60 can be written 2 to the power 30. 30 can be written 2 to the power 15. 15 can be written 3 to the power 5. Then 150 can be written 2 times 75. 75 can be written 3 times 25. 25 can be written 5 times 5. So these are the prime factors of 120 and 150. Now you have to find the LCM. LCM means you have to write these numbers as a product, as in like 2 to the power 1, 2, 3, 3 into 3 into 5. 150 can be written 2 into 3 into 5 to the power 2. Now LCM means the product of these numbers, but those numbers should have the highest power. So when you get 2, the highest power of 2 is 3. When you get 3, the highest power is 1. When you get 5, the highest power is 2. So once you simplify this one, you get 2 to the power 3, 8 into 3 into 5 times 5 to the power 2 is 25. So 24 times 25. You get 600. That's the LCM of 120 and 150. Okay, moving on to the next one. Uh, okay, that's a sentence question. In an international conference, the number of participants registered for 3 tracks: technology, HCI, and learning analytics are 150, 90, and 120. So, tech, you have 150, HCI, you have 90, and learning analytics, you have 120. Find the minimum number of rooms required to where in each room the same number of participants are seated and in the same track. So here what you have to find is HCF of these numbers. Why do you think HCF should be searched instead of LCM? So HCF is highest common factor. Highest common factor. Now here they are asking find the minimum number of rooms required to where in each room the same number of participants are seated. So now if you take 4 rooms, same number should be in there. That means highest common factor. That's why we have to calculate HCF there. So if you calculate HCF, again you can write it in prime factorization form. 150 you can write 2 to the power, let's say 75. It's 90 you can write, and 120 you can write um, to the power 3 into 3 into 5. So highest common factor is you have to take the common, what do you call, the common prime factors. So HCF means 2 into 3 into 5, which means 2 times 3 6, 6 times 5 30. So 30 people can be put in one room. Okay. Now here, 30 people are put in one room. So how many rooms? The question is how many rooms they need. So for tech people, there are 150 people and 30 people can be put in one room. So 3 rooms are required. In HCI, 90 people are there. 30 people should be put in one room. So, sorry, here 5 people, 5 rooms. Here 3 rooms. And here 120 people are there. Only 30 people can be put in one room. So you can get 4 rooms. So altogether, 12 rooms are required. Okay, now next question. Next question they are asking. Um, Briefly explain the following terms, providing each an example. First one is universally quantified statement. So universally quantified statement means, so the symbol is this one, the upside down A, which means all the elements should be contained. So the explanation here is a logical statement which says that for the certain condition is met for all the values. So when you write this quantify and x, that means for all x, a certain condition is met. So that's the universally quantified statement means. For example, if you write for all n, which is an integer, um, if n is even, n plus 2 is even. Now this is a universally quantified statement. Now here for all n, if n is even, so when you add 2 to this n, that number is also even. That is true for any number. That's why it's called a universally quantified statement. Then conditional statement. So conditional statement, the symbol is like this. If P happens, then Q happens. That's the conditional statement. If this becomes true, this also becomes true. If it is biconditional, it goes both ways. Okay. Then the next one is existential quantified statement. That means, so the symbol is like this. This means sum of x comes true for a certain condition. That means at least one element should be there for this to be true. For example, if I say there is a prime number which is even. So it should be a prime number and it should be even. This condition is met only by the number 2. So therefore, for this condition, at least one element exists. That's why it's an existential quantified statement. Okay. Okay, I'll move on to the next question. If anyone can't understand, just tell me. Next one is solving the equations. First one, x minus 1, x minus 2, x squared minus 9x plus 14 over x minus 7, x squared minus 3x plus 2 equals 0. Now the easiest method is you can factorize these quadratic equations, quadratic expressions. So what you can write is x minus 1 times x minus 2. So here once you factorize it, you can write x here. Now 14 comes by 7 times 2. So minus 7 minus 2 gets minus 9. So here x minus 7, x minus 2 over x minus 7. Here, when you factorize it, so 2, no, when you get 2, that means 2 times 1. So minus 3 comes by minus 2 minus 1 equals 0. Now what you can do is you can cut. X minus 7 is common, x minus 2 is common, x minus 1 is common. So x minus 2 equals 0. So x equals 2. Okay, the next one. Okay, let me ask you a question. Have you tried the next question? If anyone, just tell me. Anyone solve the next question? No one? Okay. Okay, here the question is 3 to the power x minus 2 to the power x plus half equals 2 to the power x plus 7 over 2 minus 3 to the power 2x minus 1. Just at least tell me whether you have solved this question. So there is an error in this question. Here, either this should be 3 to the power 2x or this should be 9 to the power x. If we have 3 to the power x here, you can't solve it. If you tried, just tell me. So once you solve it this way, So 9 to the power x minus 2 to the power x plus half equals 2 to the power x plus 7 over 2 minus 3 to the power 2x minus 1. What you can do is you can take the common, what do you call it, the bases into one side. So here 9 to the power x, you can write 3 to the power 2x. 3 to the power 2x plus 3 to the power 2x minus 1 equals 2 to the power x plus half plus 2 to the power x plus 7 over 2.
Sonali,
Yeah,
in the question, it's 3 to the power x, not 9 to the power x. The first term.
yeah, but
Okay.
yeah, that's why I asked you, because you have whether you have solved this question. If you have 3 to the power x, you can't solve it.
Oh, all right. Okay.
Have you tried the question?
No, I haven't. Okay, carry on. Sorry.
So
Thank
just
you.
try the question with 3 to the power x, you can't get an answer.
Alrighty.
Okay, so here what you can do is um, we can write these terms like this: 3 to the power 2x plus. Now here, subtraction means a division. So 3 to the power 2x over 3 equals 2 to the power x over 2 to the power half plus 2 to the power x over 2 to the power 7 over 2. Likewise. Now we can take 3 to the power 2x out. So once you take it out, 1 plus 1 over 3 plus, here you can take 2 to the power x over,
Sonali,
yeah, yeah,
that's division 2 to the power x over 2 to the power half.
yeah. Oh, yes. This one. Okay. So 2 to the power x into 2 to the power half. Thanks. So you can take this one out. Then you get 1 plus 2 to the power 3. So how did this 3 come? Is 2 to the power 7 over 2. You can write like this: 2 to the power 6 over 2 plus 2 to the power half. Sorry, 2 to the power 6 over 2 plus half. So once you add this one, 6 plus 1, 7, and the denominator is 2. So I'll take this one out. So 6 over 2 is 3. That's how I got it. Okay, once you solve this one, you get 3 to the power 2x times 4 over 3 equals root 2 times 2 to the power x. Here 2 to the power 3 is 8. 8 plus 1 is 9. Okay. So once you solve this one, I'll take the x's into one side. So 3 to the power 2x over 2 to the power x equals 9 times root 2 over times 3 over 4. Okay. So once you solve this one, you get 9 times 3, you get 27 over 4 can be written like this: 2 root 2 into root 2. So root 2 gets cancelled. Then you have 2 root 2. If I write this like, if I write this number, so 27 can be written as 3 to the power 3. And 2 root 2 can be written 2 to the power here 1 and here half. That means 3 over 2. I'll write it again. 27 you can write 3 to the power 3. Here 2 root 2 means 2 into root 2. So 2 to the power 1 into 2 to the power half. Multiplication becomes addition. You get 2, 1 plus half. Then you get 2 to the power 3 over 2, which is here. Now you can equate. I can take either this one or this one. So 2x equal, I'll take 2x equals 3. So x equals 3 over 2. If you have questions, ask me. Okay. I'll move on to the next one. Next question is, suppose that x plus 1 over x equals minus 2 over root 3. Calculate x to the power 5 plus 1 over x to the power 5. Okay. Now here you have to use the binomial theorem. So binomial theorem is a plus b to the power n. Then you have z equals 0 n ncr x to the a to the power n minus r b to the power r. So this is the binomial theory. According to this one, if we write x plus 1 over x to the power 5, so I'll take x to the power 5 plus 5c1 times x to the power 4 times 1 over x plus 5c2 x to the power 3 x squared plus 5c3 x to the power 2 1 over x cube plus 5c4 x times 1 over x to the power 4 plus 1 over x to the power 5. Now I have to simplify. I'll erase this part. Now here x plus 1 over x, they have given the value minus 2 over root 3. So I can write like this, minus 2 over root 3 to the power 5 equals, I can take this value and this value together, x to the power 5 plus 1 over x to the power 5 plus, now I have to simplify this. 5c1 means 5 factorial, I write like this, 5c1 is 5 factorial, 4 factorial and 1 factorial, there you get 5. This is same as 5c4, that means this value. Then if you simplify 5c2, That means 5 factorial, 2 factorial, 3 factorial. This is the same as 5C3. That means these two. So once you simplify these, here you get 5 into 4, 20. So 5C2 and 5C3 is 10. Now if you write it here, you get 5 times x to the power 3 plus 5C2 is 10, 10x plus 10 over x plus 5 over x cube. That's it. Now here, if I simplify this one, so 2 to the power 5 is 32 minus 32 and root 3 to the power 5 is 9 root 3 equals x to the power 5 plus 1 over x to the power 5. Here, if I take this one, you can take x out, you can take 10 out and write x plus 1 over x. Then you can write, then you have to write this one, these two. You take 5 out, 5 x cube plus 1 over x cube. Now we have to simplify this one. Equals x to the power 5 plus 1 over x to the power 5 plus 10 times minus 2 over root 3 minus 2 root 3 plus 5 times x to the power 3 plus 1 over x to the power 3. Okay. Now we have to find x to the power 3 plus 1 over x to the power 3. So how you can find it is, take the binomial theory into this one. That means x plus 1 over x to the power 3 equals x to the power 3 plus 3 x squared over x plus 3x over x squared plus 1 over x cubed. So x plus 1 over x is minus 2 root 3 cube equals x cube plus 1 over x cube plus 3 over x plus 3x. So once you solve this one, you get minus 8 into 3 root 3 equals 3 times x plus 1 over x plus x cube plus 1 over x cube. Here minus 24 root 3 equals 3 times x plus 1 over x is minus 2 root 3 plus x cube plus 1 over x cube. So once you solve this one, you get minus 18 root 3 equals x cube plus 1 over x cube. Now we can substitute this value to here. Then you get minus 288 root 3 equals minus 20 root 3 here minus 18 root 3 into 5 because there's a 5 here, and then x to the power 5 plus 1 over x to the power 5. Okay, now once you simplify this one, you get minus 288 plus 20 plus 90 root 3 equals x to the power 5 plus 1 over x to the power 5. So once you simplify this one, you get 8, 7, 1. Minus 178 root 3 is the answer. Okay, no? Any questions? Okay, I'll erase this one. Okay, next question. Simplify the following. Nine to the power x minus 1, 9 to the power x minus 2 minus 3, 3 to the power 3, x to the power half, 27 to the power minus 1, x to the power minus 3 over 2, and x to the power 1 over 3. Okay. Now the easiest method is you can turn these negative indices into positive ones. That's the easiest method to write these. Then you can write, first I'll write the integers as in like the numbers, numerical values. 9 into 9 to the power, here 9 to the power minus 3 now. So I can write it like this, 9 to the power 3. This one, and then 3 to the power 3. Okay, and here 27 to the power minus 1. You can write it like 27. Then you can write the variables. So x to the power minus 1, you can write x. X to the power half, you can write it here. X to the power minus 3 over 2, you can write it like x to the power 3 over 2 here. And here you can write x to the power 1 over 3. Now you can simplify. First of all, I'll simplify the numbers. Here you can write 1 9 gets cancelled, so 9 to the power 2. Here 3 times 2 you get 9. So 1 9 is cancelled, 1 3 is remaining. Here 3 and 3 into 3 9. Okay. And for the the x values, you get x to the power. Here multiplication turns addition. So half plus 3 over 2 means 4 over 2. Divide by 2, you get 2 over here x to the power 1, x to the power 1 over 3. Then you get x to the power 4 over 3. Here division means subtraction. Then you can write x2 minus 4 over 3. Then you can write 9 x to the power 2 over 3. That's the answer. Okay, now I'll move to the next one. Okay, next question is x plus 3 over x plus 4 divided by xy plus 3y over x squared minus 16. Okay, so how you can solve this one is x plus 3 over x plus 4. Here a division can be turned into multiplication, but you have to reverse this. Denominator to numerator and numerator to denominator. And you get x squared minus 16 over xy plus 3y. X plus 3 over x plus 4 into x squared minus 16. This is in the form a square minus b square. A square minus b square, you can write a minus b, a plus b. So here you can write x minus 4, x plus 4. Here you can take the y out. Then you have x plus 3. Now cross multiplication. So when x plus 3 gets cancelled here, x plus 4 gets cancelled here. Then you have x minus 4 over y. Okay, now I'll erase this one. Okay, the next question is a times root a plus root b over 2b root a to the power minus 1 plus b times root a plus root b over 2a root b to the power minus 1. Now this one is easier to solve. Now something like this. So if you have something like this, x to the power minus 1, you can make it positive by 1 over x. Same concept is applied here. So when you solve it, a times, I'll make it upside down. That means 2b root a over root a plus root b plus b times 2a root b over root a plus root b. Now the denominator is common, you can add it simply. That means 2ab root a plus 2ab root b over root a plus root b. Here you can take 2ab out. So once you take 2ab out, you have root a plus root b over root a plus root b. Now this gets cancelled. Then finally you get 2ab. Okay. Then next one. The square of two numbers add to 360. So I can write two variables a square plus b squared equals 360. The second number is half the value of the first number squared. What are the numbers? Okay. Now here a squared means 2b according to this equation. Then you can apply it here, substitute here. So a squared is 2b, then you can write b square plus 2b minus 360 equals 0. Now you can factorize here. So once you factorize, you get the value. Like this. So you can equate b minus 18 equals 0 and b plus 20 equals 0. Then you get b as 18, b as minus 20. Accordingly, you can write a equals, so here a squared equals 2b now. So a equals 2b square root. That means 36 square root means 6. And then here minus 20 times 2, 40. Minus 40 square root. You can't take this one. So the value is this one. Because here there is a minus sign inside the root, square root. Okay, now? If there are any mistakes, just tell me. Okay, third question. Suppose a variable name in C programming language is a string that contains uppercase letters, lowercase letters, digits, or underscore. How many different variable names can be formed in the C programming language if a variable name is 8 characters long? So here they say the first character must be a letter, either uppercase or lowercase or an underscore. And the name of a variable may contain fewer than 8 characters. That means the password can be 1 letter, 2 letter, 3 letter, 4 letter, 5, 6, 7 and 8 letters. So what you can do is you can find all the possible scenarios. So they say 1, 2, 3, 4, 5, 6, 7, 8. In this 8 character password, the first letter should be a letter, either uppercase or lowercase. So how many choices we have is 26 uppercase, 26 lowercase, digits, that means 10, and underscore. So you have 63 choices for the first letter. No, there are no numbers, either uppercase or lowercase or an underscore. You have 53 choices. Yeah. And other letters, you have 63. Why? There are digits also. So if you have one letter password, that means only the first character. That means only 53 choices are there. If you have two letter passwords, that means one should be 53, other should be 63. So 53 into 63. Likewise, 3 letter, you get 53 into 63 to the power 2. Why? Here you get another choice. Likewise, you can take all the possibilities like this. All the possibilities are 53 plus 53 into 63 plus 53 into 63 to the power 2 plus 53 into 63 to the power 3 plus 53 into 63 to the power 4 plus 53 into 63 to the power 5 plus 53 into 63 to the power 6, 53 into 63 to the power 7. Values are there. If you want to simplify this one, so if you simplify this one, I'll take 53 out, then you have 1 plus 63 to the power 2, 63, 63 to the power 2, 63 to the power 3, 3 to the power 4, 63 to the power 5, 63 to the power 6, and 63 to the power 7. Have you ever heard of geometric progression? So this is a geometric progression. If you know how to do a geometric progression sum, that means a into what do you call it? Into like this. So if you apply this theory here, you can write 1 into 63 to the power 8 minus 1 over 63 minus 1. Then you get 62 to 63. So, some kind of an answer like this. I don't know whether they have an easier method to solve this one, but this way is easy for me. I don't know. Okay, now? Yeah, I'll erase this. Next one is B. Suppose that a password for a computer system must have at least 7, but no more than 10. That means there can be 7 characters, 8 characters, 9 characters, and 10 characters. Where each character in the password is a lowercase English letter and uppercase English letter, a digit or one of the 4 special characters, how many different passwords are available? So there are 26 lowercase, 26 uppercase, a digit or 4 special characters. Then you have 6, 6, 12, 4, 16, 2, 2, 4, 5, 6. So 66 choices are there. So how many different passwords are available? For 7 characters, so if I write like this, 1, 2, 3, 4, 5, 6, 7. So there are 66 choices for the first letter, 66 for the second, 66 likewise. We have 66 to the power 7. So for 7 letters, they have 66 to the power 7 choices. For 8 characters, we have 66 to the power 8, 9, 66 to the power 9. And for 10 character length, we have 66 to the power 10. So how many possible passwords are there? You have to add up everything here. So that means 66 to the power 7 plus 66 to the power 8 plus 66 to the power 9 plus 66 to the power 10. Then they're asking how many of these passwords contain at least one occurrence of at least one of the 6 special characters. 6 special characters. I think it should be 4 special characters. So how many of these passwords contain at least one occurrence of at least one of the 4 special characters? I'll erase this part. So how you can think this one is passwords with at least one special character. Equals to total number of passwords minus number of passwords without a special character. Now if you get it like this, you can get the passwords with at least one special character. Now we have already found total number of passwords. From this total number of passwords, if you deduct the number of passwords without any special character, then you get the passwords with at least one special character. So number of passwords without any special character, that means choices. Now earlier the choices were 66. If you reduce the number of special characters, we have 62. So according to this one, you get 62 to the power 7, 62 to the power 8, 62 to the power 9, 62 to the power 10 for this one. Now you have to subtract. That means 66 to the power 7, 8, 9 and 10 minus 62 to the power 7, 8, 9 and 10. That's the answer. If you have questions, ask me. Okay, I'll move on to the next one. Solve the following. They say Mala selects 7 numbers from the set 1, 2, 3 to 11. Show that she has a pair that adds up to 12. Okay, give me a second. Okay. So they say they have a number set. Like this. Then they are asking so that she has a pair that add up to 12. So number 12 can be made with several pairs, 1 and 11. And then you can take 2 and 10, 3 and 9, then 4 and 8, 5 and 7. So these are the pairs. So there are 5 pairs here. Then they are saying Mala selects 7 numbers. So there are 7 numbers and 5 pairs. So the theory used here is the pigeonhole theory, pigeonhole principle. So when pigeonhole principle means if there are more than one pigeonhole, at least one pigeonhole must contain more than one pigeon. If you understand, it's like this. Now you have 3 pigeonholes, but you have 4 pigeons. I'll put one pigeon in here, one in here, and one in here. The remaining one can go to one of these. So at least one of these pigeonholes contain 2 pigeons. That's the idea here. Now here 5 pairs, but there are 7 numbers. From the 7 numbers, if you select 5 pairs, that means at least one pair, at least you have one pair that adds up to 12. If you can understand. Can you understand that? Okay. If you can understand, then it's fine. So if we have 5 pairs and 7 numbers, what you have to write in the answer is according to the pigeonhole principle. They have 5 pairs but 7 numbers. So there should be at least one pair which adds up to 12. That's it. That's the only answer you can write. Okay, I'll move to the next one. If you like substitute this into the pigeonhole theory, 5 pairs is the 5 pigeonholes. And 7 pigeons. So there are 5 pigeonholes and 7 pigeons. So at least 2 of them should be in one pigeonhole, right? Here, if you put 1 in each, 2 remaining, no? So you can put it like this. That's why you can say at least one pair which adds up to 12 is there among the 7 numbers. Okay, now I'll erase this. Next one. Draw a tree diagram to determine the number of subsets that can be formed from 4, 8, 11, 15 so that the sum of the elements in the subset is less than 25. 4, 8, 11, 15. So you have subset like this. We are starting from the null set. Then we have 4 choices. 4, 8, 11, and 15. So when you write 4, 8, 11, and 15, now once you select 4, there are only 3 numbers remain, 8, 11, and 15. I'll write them like this. Here, once you select 8, 4, 11, and 15 are remain. Here, 4, 8, and 15. Here, 4, 8, and 11. Now let's add these sums. So once you add here, 8 plus 4, you get 12. Here, 15. Here, 19. So all these 3 can be taken. Here, 12, 19, 23. Here, 15, 19, 26. Now 26 is greater than 25. So you can continue this one. Here 15 and 4 you get 19. Here you get 23. Here you get 26. Again, this can't be continued. Others can be continued, but here 23 is the last ones you can get. Because 8, 15, now the remaining ones are 4 and 11. So even if you take 4, 23 plus 4 is 27, which is greater than 25. So these are the last ones here. Now here we can take 8 and 4 are taken, 11 and 50. Now here you get 23. Here you get 27. So this one you can take. Here also 11 and 4 are taken, 8 and 15. So 15 plus 15 you get 30. You can't take this one. 15 plus 8 you get 23. This one can be taken. This one once you take it, 4 and 15 are taken, you have to take 8 and 11. So 19 plus 11 you get 30. You can take it. 19 plus 8, 27. Also you can take. Here 8 and 4 are taken, then you have 11 and 50, which is the same as this one. 4 and 8, 8 and 4. Okay. So this one can't be taken, this one can be taken. Here 8, 11, you have 4 and 50. Here 23. Here 34. This can't be taken, this can be taken. Here 11 and 4 are taken, 8 and 15 are remain. 15 plus 15, 30. You can't take this one. 15 plus 8, we have 23. This one can be taken. Here also 11 and 8, so 4 and 50. 19 plus 15 greater than 25. 19 plus 4, you can take 23, which you can take. Then here 15 and 4 are taken. Then you have 8 and 11. 11 you can take. 19 plus 8, 27, which is also greater than 25. So the only ones you can take are, I'll write it here. The subsets you can take are 4, 8, 11, 15, 4, 8, 4, 11, 4, 15, 8, 11, 8, 15, 11, 4, which I have written, and 11, 8, which we have written. 11, 15 you can't take. 15, 4 we have written it. And here you can write 8, 4 and 11. 8, 11, 4. 4, 11, 8. 8, 4, 11. 4, 8, 11. So these are the pairs which are less than 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pairs are there. Okay, no? Okay, I'll erase this one. Next question is how many different four-letter words can be made by using the letters of the word up to 30? Like this. So how many different four-letter words? Different four-letter words. Now if you categorize this one, there is one H, two A's, two P's, one U, one T, two L's and one E. So there are different ways to make four-letter words. First one is all the letters are different. All letters are different. Next scenario is one letter is repeated. One letter is repeated. Next one is two letters are repeated. That means here in case 2 means one letter is repeated means now let's take this is the four letter word and we have two A's. You can write A and TH. This is a word. So two letters are repeated here. That's why we take case 2. And one letter is repeated. Here two letters are repeated. That means we have A and L. So this is also a scenario. Now you have to find the number of possible ways for each scenario. That means we'll take case 1. So case 1, all different letters. That means number of different letters are 1, 2, 3, 4, 5, 6, 7. From these 7, you have to select 4. And 4 factorial. This 4 factorial means, now let's say I selected the words H, A, T, L. Now these 4 letters can be changed. I can write it like this as well and this as well. To find the number of possibilities here, so there are four possible positions. So you factorial it like this to find the number of different positions they can take. So 7C 4 times 4 factorial you get. For the first case. For the second case, now one letter is repeated. If one letter is repeated, we have to take 1, 2, 3, 4, 5, 6, 7. From 7 letters, one letter is repeated. Then we have to find, then you have only left with 6 letters. You have to choose a letter from these 6. So 62, sorry, 62 into no 62 into 4 factorial 6c2 into 4 factorial. One letter is repeating. That means we have to divide by 2 factorial. When you are something getting repeated, you have to divide by that number. Now, you will understand that one when you get 2 letters are repeated. So 6c2 into 4 factorial is for the positions, number of positions for the each letter. And 2 factorial divided by 2 factorials means because one letter is repeated because of the repeated thing. That's it, no combinations. We have 4 possible ways. Then the third scenario, 2 letters are repeated. So 2 letters, once you get 2 letters are repeated, there are only 3 letters which has 2 each. So from these 3, you have to choose 2. So 3c2. Then for the 4 positions, you write 4 factorial. Because 2 letters are repeating, 2 factorial, 2 factorial. Then you have to add everything. Here, in the second case, now let's take one letter. I'll take A. So A is repeating. Then you have only 1, 2, 3, 4, 5, 6 choices left. From these 6, you have to choose 2 letters. Okay. That's only for A. What about P and L? So there are 3 ways. You have to multiply this by 3. So once you simplify the answers, here you get 840. Here you get 540. Here you get 80. So altogether, I think it's 1,398. I hope you understood that one. If you have questions, ask me. Okay, moving on to the next one. Five men and 5 women were invited by a married couple for a dinner party. Determine how many ways these 12 people can be seated around a round dinner table if the married couple should be seated together. Okay. So this is circular permutation. Circular permutation, the theory is n minus 1 factorial. If there are 12 people, it should be 11 factorial. Likewise. Now there are 12 people here. 12 people are seated around this. but the married couple should stay together. So we'll take those two as one person. So this couple and the rest of the people, that means 10. These 10 and this one person, you get 11. N equals 11. Therefore, the circular permutation equals 11 minus 1 factorial, which is 10 factorial. But this married couple can also change their seeds. They can also interchange the seeds. So this should be multiplied by 2. That's the answer. Okay, I'm erasing this one. Next question. Solve the following logarithm equations. Okay, you have 5x plus log 2 4 to the power 2x equals log 3 27x minus 1. Okay, you can write it like this: 5x plus, here when you have power inside here, you can take the power in front of the log. That means like this: 2x log 2 to the power 4, log 4 to the base 2. No, log 2 to the base 4. I don't know, something like that. Then here x minus 1 is the power. You take it in front of here. X minus 1 times log 3 to the base 27. 4 can be written 2 to the power 2. So you can write 2x log 2 to the base 2 to the power 2. X minus 1 log 3 to the base 27 can be written 3 to the power 3. Here, 3 to the power 3. Again, you can take these powers in front, into the front. Then you can write 5x plus 2 to the power 2, 4x. Log 2 to the base 2 means 1. Here, 3 into x minus 1. Log 3 to the base 3 is 1. Now you have to simplify this one. You get 9x equals 3x minus 3. So you take this 3 into this side, you get 6x equals minus 3, x equals minus half. That's the answer. Okay, next question. Okay. Next question we have y equals log 10 plus 3 root 10 plus log 10 plus root 90 plus root 90 plus log 10 minus 90 plus root 90. So how you can solve this one is, in logarithm addition, log m plus log n equals to log m into n. That means log 10 plus 3 root 10 plus log, here this one and this one can be multiplied. 10 plus 90 plus root 90 into 10 minus root 90 plus root 90. Then you can multiply these. You have 10 plus 3 root 10 plus log. Now this is in the form a plus b, a minus b. A plus b, a minus b means a square minus b square. So here a squared is 100 minus, here it's 90 plus root 90. So once you solve this one, you get log 10 plus 3 root 10 plus 100 minus 90 means you get 10 minus root 90 means 9 into 10. So when you take 9 out of the square root, you get 3 root 10. Here also addition means you can multiply. Then here you can write 10 plus 3 root 10 into 10 minus 3 root 10. This is also in the form a plus b, a minus b. So here, once you simplify this one, a plus b, a minus b, you get a square minus b squared. So 100 minus b squared, 3 times 3, 9, and into 10, 90. So here, log 10. Here, if they haven't specified the base, it's usually base 10. So log 10 to the base 10 means 1. That's the answer. Next one. Um, 6 log a to the base 3 plus 4 log a to the base x minus log a to the base 9 equals 2 log a to the base 25. So how you solve this one is, you can take these numbers, digits in front of the log as powers to these ones. So if you write it like this, log a to the base 3 to the power 6 plus log a to the base x to the power 4 minus log a to the base 9. That means I can write it as t to the power 2 equals log a 25 to the power 2. Now if you solve this one, now here addition and subtraction. That means addition means multiplication, subtraction means division. So you can write it like this: log a to the base 3 to the power 6 into x to the power 4 over 3 to the power 2 equals log a to the base 25 to the power 2. That means 5 to the power 4. Now, because the bases are the same, you can equate these two. We can like cut the log here. Then we have x to the power 4 equals 5 to the power 4. Here, once you simplify this one, you have 3 to the power 4 remaining here. I'm taking that one to the denominator, then you have 3 to the power 4. That means here 5 over 3 into the power 4. Therefore, x equals 5 over 3. Okay, now? Okay, I'll move on to the next one. Okay, next question is, suppose functions f and g are defined as follows. Show that fx plus gx is a constant function. Here what you can do is, I'll take fx and simplify it first. Then I'll take gx. So fx is 2 square root 1 minus x over 1 minus x square root minus 3 1 minus x square root. Uh, 1 plus 6. So once you simplify this, how you simplify this one is, now the denominator is in square roots. Normally we don't keep it like that. So we have to remove the square root. To remove the square root, you have to square these square roots. So how you can square the square root is, I can write something like this. So what I wrote here is the plus of this term, 1 minus x square root plus 3 into 1 plus x square root. Why? Because now this is in the form a minus b. If I multiply it by a plus b, then you will get a square minus b square, which will, so the squares will remove the square root, and that's what we want. That's why we multiply it like this. Then if you multiply it in the denominator, you have to multiply it in the numerator. 1 minus x square root plus 3 into 1 plus x. So once you multiply this one, you get 2 into 1 minus x plus 2 times 3, 6, 1 minus x squared square root over 1 minus x minus 9 times 1 plus x. So once you simplify this one, you get 2 minus 2x plus 6 1 minus x squared over 1 minus 9, you get minus 8 minus x minus 9x minus 10x. Now here the whole thing can be divided by 2. Then you get here 1, here x, here 3, here 4, and here 5. If you multiply both sides by minus 1, then you will get a positive answer for here. Here 4 plus 5x minus 1 plus 6 minus 3. So I'll take this one as equation number 1. Then I'll move on to the next one because we can't simplify it further in here. I'll take gx. So gx equals 3x over 2x plus 2 minus 4 1 minus x squared. Here also you have a square root in the denominator. To get rid of that, we can write the now here it's 2x plus 2 minus 4 square root 1 minus x square root. Then we can write something like this. X plus 2 minus 4 1 minus x squared multiplied by 2x plus 2 plus 4 into 1 minus x squared. Here also you are multiplying the same thing. Now once you simplify this one, you get 3x times 2x plus 4 plus 4 1 minus x squared over 4 into x plus 2 squared minus 16 into 1 minus x squared. So I'll simplify it here. We can divide the whole thing by 2 here. Here 2, here also 2, here also 2, 2 and 8. Now if you simplify this one, you get 3x squared. I don't know whether you can see it. 3x squared plus 6x plus 6x 1 minus x squared over 2 into 2x squared plus 8x plus 8 minus 8 plus 8x squared. So once you simplify this one, you get 3x squared plus 6x plus 6x 1 minus x squared. Here plus 8 and minus 8 you can cancel. 2x squared plus 8x squared you get 10x squared and 8x. Here you can divide everything by x. You can cancel x here. So here x is cancelled. And in the denominator, I can take 2 out. I'll take this one as equation 2. Now what we have to find is fx plus gx should be a constant. Now this is fx, this is gx. Let's add those two. 1 plus 2. Here denominator is 4 plus 5x. Here 2 times 4 plus 5x. Then this should be multiplied by 2. Then you get minus 2 plus 2x minus 6 times 1 minus x squared plus 3x plus 6 times 1 minus x squared over 2 times 4 plus 5x. Now here plus 6 and minus 6 gets cancelled. Okay, and 3x plus 2x you have 5x minus 2 plus 6 you have plus 4 over 2 times 4 plus 5x. Here 5x plus 4, 5x plus 4 gets cancelled. You get half, which is a constant. So the answer fx plus gx is a constant. Okay. Then I'll move on to the next one. Next question is they are asking show that propositions P goes to Q bar and P goes to R bar and P and Q O R bar. So they're logically equivalent using a truth table. So these are easy. So I'll write P Q R and Q bar R bar. I'll take this whole thing as A, this whole thing as B. Then I'll take A, B, A goes to B. So for the values, I can write it like this. True, 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 false, false, false. Then true, false, like this. Now Q bar means the opposite of this. That means false, false. R bar means like this. Now A means P goes to Q bar. This one and this one. So true goes to false is false. True goes to true, true. True. These are all true. B, P goes to R bar. So P goes to R bar, we get false, true, false, true, 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 true. Now A goes to B. Here true, true, false, true, true, true. Like this. Ah no. What have I done? So here this is A and B. This is wrong. So A and B now. Here false, false. These are the answers. Now this is the truth table for this part. So only the first three are false here. We'll take the other one. Other one is PQR. So QOR. QOR. I'll take this one as C. And then we have P and C. P and C bar. So if you consider these ones, QOR. So true, 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 false, true, 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 false. Here P and C. That means this one and this one. True, 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 false, 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 false. Other side. So false, false, true, 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 and true. Here also, the first three are false. So both of them are logically equivalent. Next one. Decide whether the following proposition is a tautology or a contradiction by developing a series of logical equivalences. Okay. Now, if you have something like this, P goes to Q, O, P goes to Q bar. Now, there is a theory like this. Now, here the first term is equal. So, the theory is like this, P goes to Q and P goes to R. If the first two terms are equal and there is an O here, then you get P goes to Q O R, like this. So same thing apply here. Here Q is Q, R is Q bar. So once you solve this one, you get P goes to Q O Q bar. Now here, if we take Q as true and Q bar as false, true or false, the answer is always true. Here, either it's T and F or F and T. Either way, when you perform an O operation here, the answer is always true. Therefore, this expression is a tautology. I think all the questions are done. Yeah, we did the paper. Any questions so far? Anything you need to clarify? That's my mouse, don't worry. Anything you need to clarify?
There's like two questions that I didn't get the right answer, but I will send them to you later. You can get to me when you're free. Is that okay, Sonali?
Okay, yeah. Which one?
Um, like very early ones. Wait, I have not. Third one in something. Wait. Well, let me see the question number. It's okay, no
Third
rush.
one.
Yes, in
Okay.
the early
You send
ones.
me the question, I'll give you the answer.
Yeah, that's easy. Okay, thank you.
Okay. Yeah, sure. So I was planning to do the matrices revision, but I'm too tired. Is it okay if we do it tomorrow morning? What do you all say? Because tomorrow, so I made a paper, so that paper is covering all the things from the syllabus. So we were like planning to discuss that paper tomorrow. Before that paper begins, I'll cover the matrices lesson, like just a small revision. Is it okay?
Yeah, dude, that's fine. You rest now. Go sleep.
Okay, thanks, guys. So, any other questions you want to ask? Isum Nidhi.
I guess so, because usually he
Yes.
would speak, right? If he was there.
Isum recording off karanda. Okay, guys. Then I'll that's it. Bye, people.
Thank you,
I'll see you tomorrow.
Sonali. You're the best.
Yeah.
Thank you so much,
Thank
okay?
you. Thank you.
Right, rest a